My name's Lynette Whitson, and I'm going to tell you about cluster analysis. If you want some additional resources, I recommend starting with the Statistics Solutions site and then proceeding to the IMB website, which includes information for each type of cluster analysis. Last, the cluster analysis by Aldendorfer and Blashfield gives a lot of detail. Think about the way that you cluster or group animals based on similarities. A dog, a cat, a duck, a crow, and an angelfish could be classified based on color or class. But what if you wanted to group these animals based on multiple characteristics, or maybe even less evident characteristics? Instead of classifying animals just by color or just by class, you could group them together based on multiple variables such as partnering tendencies, likelihood to be domesticated, and propensity to live in a pack. In the social sciences, we use cluster analysis to group people together based on variables we deem appropriate or important. Cluster analysis is defined as exploratory data analysis that rearranges a dataset into basically homogeneous groups or clusters through a multivariate statistical method. The overall question being asked is, how can my dataset be grouped into relatively homogeneous clusters based on similarities and differences in variables x, y, and z? So the goal of cluster analysis is to create typologies and classifications referred to as clusters. These clusters are homogeneous groupings of cases or data with similar characteristics. However, further analyses are necessary if you are wanting to discover the why behind these groups. For example, you may find 3 satisfaction-based typologies of people when you group them based on satisfaction in home life, social life, work life, and school life. However, if you want to know what causes these 3 groups to emerge, or what causes these differences in satisfaction, you would need to complete additional analyses. The why behind your results does not emerge from a cluster analysis because it is exploratory. Generally, a cluster analysis will be run during the exploratory phase when the hypothesis is being developed. In turn, the research project will be guided by the resulting clusters and that hypothesis that is from them. SPSS includes 3 cluster analysis methods. K-means clustering creates a number of clusters defined by the researcher. Hierarchical clustering involves multiple interconnected levels of groups, and 2-step clustering combines the other 2 methods by starting with pre-clustering before proceeding to hierarchical analyses. All cluster analysis studies share 5 steps. The first step in cluster analysis is the selection of a sample or the decision of what group will be evaluated. Are you looking at elementary school students? Would 5th grade or 1st grade students be more appropriate? After those decisions are made, your sample could come from randomly selected Knoxville elementary schools. The second step is the definition of a set of variables on which to measure the entities in the sample. Are you interested in looking at student achievement? Then it would be helpful to group students based on their math, reading, and science achievement scores instead of on other variables such as social acceptance, self-esteem, and enjoyment of school. Step 3 is the measurement of similar data points. Depending on cluster analysis type, you may or may not be able to choose similarity measurement. Distance functions, such as Euclidean distance, are most commonly used, but similarity could also be based on correlation. Refer to Aldendorfer and Blashfield for more information. Step 4 is the cluster method, or the definition of cluster formation rules. For example, when calculating the distance between 2 clusters, you can use the pair of nearest objects, or the pair of furthest objects, or a compromise between these methods. Refer to Neuresis, starting on page 371, for more information. The final step, step 5, includes the validation of your results, which can be completed through multiple ways, such as the cophonetic correlation and Monte Carlo procedures. However, simple replication, or finding the same clusters in different data sets, is the most highly recommended of the possible procedures. Assumptions for this analysis differ based on type of clustering. The assumption that Euclidean distance is the appropriate measurement for your data and that the correct number of clusters have been selected are both assumptions for K-means clustering. K-means and hierarchical analyses need the same measurement scales or standardization of variables and assume that all relevant variables have been included. 2-step cluster analysis assumes the independence of variables. Therefore, data obtained through repeated measures is inappropriate. Normal distribution for the continuous variables and multinomial distribution for the categorical variables is also assumed in 2-step cluster analysis. There are several limitations for cluster analysis. If a single case is dropped from a dataset, all of the clusters will be affected. Also, poor choices at the beginning of the analysis can drastically change the ultimate outcomes, and multiple random runs are necessary for k-means and two-step cluster analysis because these results rely on the order of data. How could this analysis be used in research? Novotny explored the ways hard science faculty could be grouped based on research commercialization. The research was published under the title The Heterogeneity of the Academic Profession, the Effect of Occupational Variables on University Scientists' Participation in Research Commercialization. Novotny used a two-step cluster analysis, not only because the dataset was large, but also because the ideal amount of groupings was not known. Additionally, two different types of data, categorical and continuous, were included. Therefore, two-step analysis was the only appropriate form of clustering based on the other method's limitations. The variables included in the analysis were 7 items within a research commercialization scale. Examples of items included, did you provide consulting for private businesses? And did you apply for patents? Therefore, the academics were grouped based on their Likert scale responses to these 7 questions. The cluster analysis found that the researchers could be divided into 3 groups. Traditional faculty do not or rarely commercialize research. Market-oriented faculty commercialize research pretty often but don't have their own firm. And academic entrepreneurs not only work as academics but also have their own research commercialization business or work for a firm.